Okay, now let's do a couple of examples on the topic of limits at infinity. All right, so we have example limit as x goes to positive infinity of 3x minus 2 divided by 2x plus 1. Now, look at these two values, two terms, so 3x and 2x. So the leading terms in numerator and denominator have the degree of 1. Both are the same, so we can from the get-go say that the limit is equal to 3 over 2, and we have the vertical asymptote at x equals to 3 over 2. If you want to do it a longer way, you can simply just divide everything by the leading term or the leading x of the denominator. So you would have limit as x approaches infinity of 3x over x minus 2 over x divided by 2x over x plus 1 over x. And now you'll have limit as x approaches infinity. So these x's are gone. We have 3 minus 2 over x stays divided by these x's are gone as well. So we have 2 plus 1 over x. So now as we send our x to infinity, we see that we have these two terms going to 0, right? This one goes to 0, this one goes to 0. So we have 3 minus 0 over 2 minus 0. So this is where you get that 3 over 2, or you can say it from the very beginning because these two x's are of the same power. All right, let's look at another example. Here we have limit of 2x squared plus 1 all squared divided by x minus 1 squared times x squared plus x as x goes to infinity. Okay, so let's look at what is the leading x or the leading term in the numerator. So we have x squared, but it's also squared. So technically we have 4x to the fourth as our leading term, right? Now, and then we have the rest is something, right? In the denominator now, we have x, but it's squared, so that's going to be x squared. And the other term also has, or the other factor rather, also has this x squared. So when you do the foiling after you apply this square here, so you when you do the foiling, you'll have times another x squared. So the denominator in this case also is x to the fourth power, has the leading term of x to the fourth power plus something else. So we will be looking only at the leading terms of numerator and denominator and comparing their the power of their x's. So this one is x to the fourth, this one is x to the fourth. So we can technically just not cancel them, but it's the same as in the previous example. The limit will be just the ratio of numerator and denominator, and it will be 4 over 1 or just 4. And that is it. Again, you can do the same procedure. You can open this parenthesis, open these parentheses, and then multiply and FOIL that all together and have a very, very big expression, but eventually all the other terms will be something like this, something over x or over x squared or x cubed. So you will not need to worry about those because you will have, you will send them to 0 anyway. So you're only looking at the leading terms. Okay, so let's go to another example. In this case, we have a limit of square root of 4x squared plus 3x plus 2x outside of the square root as x approaches negative infinity. All right, so now what we need to do first, well, in this case, it's very difficult to see what's actually going on because if we write here, if we just plug in negative infinity, we get negative infinity squared plus positive and plus negative infinity and then plus 2 times this negative infinity. So we essentially have infinity minus infinity minus infinity. So this expression doesn't make any sense and you should not write it this way. So what is the limit in this case? Okay, so sometimes it's easy to multiply by the conjugate, right? However, first, let me make a substitution. I want the all of that to send to positive infinity, right? So if I let let's say a to be equal to negative x, right? So then from here, then x is equal to negative a, right? So now where I see my x in the expression, I will plug in negative a. And also, when I send my x to negative infinity, my a will be sent to negative times negative infinity, which will give me a positive infinity, right? So if I do this substitution, I will not only need to substitute everything in the expression for a, but also the limit that I sent my x to, or in this case, I will need to change that for a. So I will have then, so limit as a approaches positive infinity of 4 times negative a squared plus 3 times negative a plus 2 times negative a. So when I simplify it, I get limit as a approaches positive infinity of 4a squared minus 3a minus 2a. Okay, so now it will be easier for us to work. So let's now multiply by the conjugate of this expression, and I will have limit as a approaches infinity of 4a squared minus 3a minus 2a times square root of 4a squared minus 3a plus 2a, and I divide by the same expression, 4a squared minus 3a plus 2a. And in this case, I will have limit as a goes to infinity of 4a squared minus 3a minus 4a squared, right? So this is my radical expression, former radical expression, and negative 4a squared. That is my 4a squared, right? And then in denominator, I have, let me close that. I have radical 4a squared minus 3a plus 2a. Okay, so now let me simplify it a bit more, right? So I have limit as a approaches infinity of, so these are gone, right? 4a squared minus 4a squared, just 0. So in the numerator, I have 3a, negative 3a. So let me write it, factor it out. So I have a squared times 4 minus 3 over a, right? Because I'm factoring out two a's. And I have only one a here, so I will need to kind of borrow one from there. And then plus 2a here. So now remember that square root of a squared, this is just the absolute value of a, or module of a. So I would have limit as a approaches infinity of negative 3a over module a times 4 minus 3 over a. Let me make it a bit bigger. Plus 2a. So now I can factor out a from here, or I can just simply cancel a in numerator and in both terms of the denominator. Remember that you cannot just divide or cancel a's in one of the terms and not in the other. You need to do that in both terms, or factor it out first if you don't see it right away, and then cancel. Okay, so now we have limit as a approaches infinity of negative 3 over square root of 4 minus 3 over a plus 2. And now I am ready to send my a to infinity, and this one will be gone to 0. So I have negative 3 over square root of 4 plus 2, which gives me negative 3 over 2 plus 2, that's 4. And this is my limit for this function. And the last example that I want to show you right now is this one. Okay, so limit as x to the fourth minus 3x squared plus x divided by x cubed minus x plus 2. So if we plug in, so remember that we need to look at the first terms, right? When we send the x to infinity or negative infinity, you're only, in most of the cases, when you have the rational expression, you're just looking at the first terms and see what's happening. So in this case, when you divide by the leading term of the denominator, you would have limit as x approaches infinity of x to the fourth over x cubed minus 3x squared over x cubed plus x over x cubed over x cubed over x cubed minus x over x cubed plus 2 over x cubed. So now here we can cancel the 4 and x cubed. Here we can cancel x squared and 2 x's from the x cubed. And here 1x, and this will be x squared in the denominator. Here we can cancel everything and it's just 1. Here we can cancel 1x in the numerator and 1x in denominator, leaving x squared in the denominator. And this one stays the same. So now what I have is limit as x approaches infinity of x minus 3 over x plus 1 over x squared over 1 minus 1 over x squared plus 2 over x cubed. So now when I send my x to infinity, I see that this one is going to 0, this one is also going to 0, 0, and this one is 0. So I have infinity minus 0 plus 0 over 1 minus 0 plus 0. So that's essentially we have an infinity. So remember that when the power in the in the numerator is bigger than in denominator, we do not have any vertical asymptotes, and the limit would be infinity. Thank you.